Okay, students, uh, I will add your lab instructor to this conversation. Okay, so give me a few minutes.
Okay, sir.
Okay, students, we are still waiting for your instructor to join. So he will be joining shortly. Okay, so just a heads up. So basically, I will go through the theoretical part. After that, uh, your lab instructor, sir, he will show you a demonstration, a live demonstration of the circuit. Okay, so I think he is in the lab class right now, and he has the equipments with him, the breadboard and everything. So he will just give you a demonstration of the circuit. Okay, so please wait a few more minutes. সবুজ ভাই আপনি আছেন? সবুজ ভাই আপনি শুনতে পাচ্ছেন?
জি স্যার।
ওকে ওকে। সো আমি ওদেরকে থিওরিটিক্যাল পার্টটা দেখাচ্ছি। সো আমি দেখানোর পর আপনাকে হ্যান্ড ওভার করে দিব, তাহলে আপনি তখন লাইভ ডেমনস্ট্রেশনটা দেখিয়ে দিয়েন ওদেরকে। ওকে। So we were over here, right? So as I was saying, that CMOS is actually what? A very important technological revolution, right? So সবুজ ভাই আমরা এক্সপেরিমেন্ট নাম্বার 8 করছি।
আচ্ছা ঠিক আছে স্যার।
আচ্ছা ঠিক আছে। Okay. So as I was mentioning that for the case of CMOS, right? It can actually be reduced down to a very small form factor because of the advancement of VLSI technology. And we can use CMOS to make any type of circuit, okay? Whether it is an adder circuit or you all learned about it, this, right? In your midterm syllabus, adder circuit, subtractor circuit, right? Full adder, half adder. So we can make all those by using a CMOS, and also inverter, NOT gate, also basic gates as well, okay? So what are the important characteristics of CMOS? So one of them is it has a high noise immunity. That means it is not prone to noise at all. Okay, so you can place CMOS in a circuit which is noisy and still it will function very well. And also it has low static power consumption. That means when you are not using a particular device, right? So normally if you, for example, put your smartwatch, right, unused, it will have a power for a longer period of time, right? The power will deplete eventually, but very slowly. Why is that? Because it has low static power consumption. It does not draw power if you do not use it. Okay, the leakage power is small. So that is one of the advantages. Okay, so now there are also other devices, right? There are TTL, which is called transistor logic. So you have learned about this in your midterm syllabus. Then there is RTL, resistor transistor logic, right? There is also DTL, diode transistor logic. So these different types of transistor logic, these was used before the arrival of CMOS. Okay, so the early computers, they were made using RTL, TTL, and DTL, because in that time we did not have such advanced technology to actually manufacture or fabricate CMOS. So in those times, we used different combination of transistors, resistors, and diodes to actually implement our circuit. Okay, so that is why before those were used. So by using RTL, TTL, you can also implement the same inverter circuit or adder circuit, subtractor circuit, but those will be not very efficient compared to CMOS. Okay, and some of the advantages of CMOS are given compared to TTL. So as you can see that CMOS gate input draws far less current. So CMOS actually takes less current compared to TTL, right? And this is the reason for the efficiency. And then CMOS gate are able to operate on a much wider range of power supply. That means you are not limited to a certain power source. You have flexibility. So that's another advantage. And the third one is that CMOS transistors are smaller in size and provide less power dissipation. That means they are small and they actually do not dissipate a lot of power when not used. So the power depletion is less. Okay, so over here, the first circuit that you can see is an NMOS inverter with ohmic resistive load. NMOS means, so this is an NMOS. And again, MOSFET are of two types, PMOS and NMOS. So depending on the region that you have in the substrate layer, that whether it is a P substrate, whether it is the N substrate, you have different types of MOSFET. Okay, so this particular diagram is that of an N MOSFET. Okay, so you have the N MOSFET, you have the gate terminal, you have the drain terminal, you have the source terminal. So these are the different terminals of the MOSFET. So the drain terminal is connected to a resistor, and from that resistor to a voltage supply. So the voltage supply is actually powering this N MOSFET. And this N MOSFET configuration is working in such a way so that when you apply high voltage at VDD or 5 volt, right, your output will be 0. V0 will be 0. If you apply a low voltage, that means VDD is 0, then your output voltage will be high or plus 5 volt. So what is happening? Basically, it is working as an inverter. So if you give a high voltage at the input, you are getting a low voltage at the output. If you are giving a low voltage at the input, you are getting a high voltage at the output. So basically, it is working as an inverter. So that is why it is an NMOS inverter with ohmic or resistive because you have a resistor. Okay. After that, you have a NMOS inverter with NMOS square. So that means the NMOS inverter, this circuit is an NMOS inverter, but now you do not have a resistive load. Previously, it was a resistive load, right? But now you're using the NMOS itself as a load. So basically, you have two NMOS. One is working as an inverter, the other NMOS is the load itself. So you have your VDD connected to one of the NMOSes, right? And the output between this other one. And this is the NMOS NAND gate. So this circuit that you can see here will work as an AND gate. So you have input A and B, right, which is connected to these two NMOSes. And then you have an NMOS at the top, which is working as a load. And from here, you have your output. So this is the NMOS NAND gate. And finally, you have your NMOS NOR gate over here. So this one is working as a NOR gate. So you have two NMOSes, right? These two NMOSes are connected in parallel to one another, inputs A and B. And from there, it is going to a common NMOS load, which is connected to a voltage supply, VDD, and your output. Okay. But our main focus is not NMOS. Our main focus is CMOS for this case. Okay. So we want to see that how CMOS actually works. So as I mentioned, right, that what is the main difference between CMOS and a normal MOSFET? The thing is, for the case of CMOS, it is made of a PMOS and an NMOS. So that is why it is called a complementary MOSFET, because it consists of both a P-type MOSFET and an N-type MOSFET. Okay. So we have a both PMOS and an NMOS. This is the circuit diagram of a CMOS inverter. This inverter circuit will actually convert the output. So when you give a high input, it will give you a low output. When you give a low input, it will give you a high output. So basically an inverter or a NOT gate. And as you can see, you have two different types of MOSFET connected together, a PMOS and an NMOS connected together. And the one of the output from here is going to the source terminal, is going to the ground, and the other is connected to the drain. So a simple CMOS inverter. After that, you have a CMOS NAND gate, right? So this circuit will work similar to a NAND gate combination. So depending on the input, the output that you will find at Y terminal will be that of a NAND gate. So you have two NMOS, right? You have CMOS connected together, right? This entire circuit is made of CMOS connected together in such a way so that you get the output which works as a NAND gate. And this is the CMOS NOR gate. Okay. So this is basically the different configuration. As you know, that a MOSFET has drain, gate, and source terminal. Okay, and your instructor sir will show you that how to basically connect these different parts together in a circuit. So this was basically the first part of your manual. Okay, the second part is designing half adder using CMOS. Okay, we will look into it later. So this is basically making a half adder using CMOS. As I told you in the very beginning, that you can use CMOS to make half adder, to make full adder, to make subtractor, half subtractor, full subtractor. So it can be used to do any binary calculation. Okay, and a half adder is given here. So basically how you can do the half adder using a CMOS. So this part is for your simulation. Okay, so when you make the lab report in your simulation part, you have to design a half adder using CMOS. Okay, so this is for your simulation part. So when you will be making the lab report for this experiment, so for the simulation part, do this half adder using CMOS. That's it. And for the previous part, your instructor sir will show you, right, how the circuit is done. What you can do is take a screenshot of the page. Take a screenshot, crop it, and then add it to your lab manual. So I think then this will be very easy for you. Okay. So I think for this experiment, we can see the CMOS inverter, and I think we can see the CMOS NOR gate. Right? So সবুজ ভাই,
জি স্যার।
তাহলে ওদেরকে CMOS ইনভার্টার সার্কিটটা আর CMOS নট সার্কিটটা যদি একটু ডেমনস্ট্রেট করে দেখিয়ে দিবেন।
আচ্ছা ঠিক আছে স্যার, দেখাচ্ছি।
স্যার
ইয়েস
স্যার আমি জানি না কেমনে কিভাবে স্যার, বাট আমার কিভাবে কি জন্য জানি কি মিটিং দিয়ে রিমুভ হয়ে যাচ্ছে আমি।
I did not get you. Can you repeat?
স্যার মিটিং দিয়া মানে রিমুভ হয়ে যাচ্ছি আমি, নিজে কিন্তু বের হচ্ছি না।
আমি বুঝতে পারছি না আপনার কথা।
স্যার মানে আমি ক্লাসে বসে আছি স্যার, কিন্তু হঠাৎ করে আসছে যে আই হ্যাভ বিন রিমুভ ফ্রম দ্য ক্লাস, এরকম কিছু আসছে স্যার।
That should not be possible because I don't think anyone
Yeah,
has the.
আমি স্যার আমি তো 5 বার জানতে 5 বার।
Okay,
জি
okay,
স্যার,
okay. Anyone else facing the same problem?
জি স্যার আমার হচ্ছে স্যার, এই প্রবলেমটা হচ্ছে।
Okay, let me see if I can lock any function in the Teams which allows other members to do such thing. Wait a minute. I think it is mostly because of your internet connection, because I don't think anyone else has the permission to actually remove any attendee from this meeting. That should not be possible.
স্যার তাহলে তো বলবে যে ক্লাস ক্যান্সেল বা তেমন কিছুটা হবে বা সেরকম কিছু হবে না, বাট এখান থেকে বলতেছে রিমুভ করে দিছে।
Okay, okay, let me see. Let me see what I can do. Okay. Okay, so let us wait for your instructor, sir. So once he organizes everything, he will start the video. And then we will be able to see the demonstration of a CMOS inverter and a CMOS NOR gate.
স্যার এটা কি কানেকশন দেখাবো নাকি শুধু আউটপুটটা দেখলে হবে?
হ্যালো সবুজ ভাই, শুনতে পাচ্ছেন?
স্যার এটা কি শুধু আউটপুট দেখাবো নাকি কানেকশনটা দেখাবো?
আচ্ছা, আমার মাইকটা অফ ছিল। আচ্ছা, ওদেরকে জাস্ট এমনি দেখিয়ে দিন যে ব্রেডবোর্ডের সার্কিটটা দেখতে এরকম, এই কম্পোনেন্ট এইভাবে কানেক্টেড, এবং ইনপুটের সাথে আউটপুটে এরকম আসছে, একটা কম্পারিজন।
আচ্ছা ঠিক আছে স্যার। আমাদের এটা CMOS NOR গেট। হ্যাঁ, ফার্স্ট আমরা এটা নিয়েছি হচ্ছে PMOS আর এটা হচ্ছে NMOS।
স্যার
PMOS হচ্ছে না,
দেখা যাইতেছে না স্যার।
দেখা যাচ্ছে না।
স্যার লেখা যাচ্ছে the meeting is locked.
এখন দেখা যায়? PMOS
হ্যাঁ, সবুজ ভাই, দেখা যাচ্ছে।
940 আর 540। আমরা একটা PMOS নিয়েছি আর একটা NMOS নিয়েছি। হ্যাঁ, এটা হচ্ছে CMOS NOT গেট আর কি, ইনভার্টার। এটা আমি কানেকশন দিয়েছি, আমার কানেকশন কমপ্লিট হয়ে গেছে। এটা হচ্ছে এই যে, যেহেতু নট গেট 0 তে 1, এই যে 1 is 0। ইনপুট যখন 0, আউটপুটে 1। আউটপুটে যখন 1, এই ইনপুটে যখন 1, আউটপুটে 0। দেখা যাচ্ছে?
Students, make sure to take a screenshot.
Yes sir. স্যার স্যার যদি পরে একটা পিকচার দিয়ে দিত স্যার ভালো হতো স্যার, কারণ এখানে অনেক স্যার ঝাপসা।
সবুজ ভাই,
জি স্যার।
আপনি পরে সার্কিটটা খোলার আগে একটা ছবি তুলে নিয়েন।
আচ্ছা ঠিক আছে স্যার।
ছবি তুলে টিমসে একটু কষ্ট করে দিয়ে দিয়েন, তাহলে সবাই পেয়ে যাবে।
আচ্ছা ঠিক আছে স্যার। ওকে,
থ্যাংক ইউ।
থ্যাংক ইউ স্যার।
CMOS NOR গেট হয়ে গেছে স্যার।
আচ্ছা সবুজ ভাই, তাহলে ওইটাও সার্কিটের ডেমনস্ট্রেশনটা যে ব্রেডবোর্ডে কিভাবে কানেক্টেড আছে এবং ইনপুট আর আউটপুটটা কিভাবে আসছে এটা একটু দেখিয়ে দেন কষ্ট করে ওদেরকে।
ঠিক আছে স্যার। দুইটা PMOS নিয়েছি আর দুইটা NMOS নিয়েছি। হচ্ছে এই দুটো হচ্ছে PMOS আর এই দুটো হচ্ছে NMOS। হ্যাঁ, তাহলে আমাদের এটার আউটপুট হচ্ছিল 0 0-তে আউটপুট 1, তারপর হচ্ছে 0 1-এ আউটপুট 0,
এইভাবে ল্যাব হয়
1 0-তে আউটপুট 0 আর 1 1-এ আউটপুট 0। হ্যাঁ, শুধু 0 0-তে আউটপুট 1 হবে। দেখা যাচ্ছে?
হ্যাঁ সবুজ ভাই দেখা যাচ্ছে।
Yes, sir.
এই দুইটা ছবি দিয়ে দিব স্যার।
হ্যাঁ সবুজ ভাই একটু কষ্ট করে ছবি তুলে আমাদেরকে দিয়ে দেন, তাহলে স্টুডেন্টরা পেয়ে যাবে আর কি, ল্যাব রিপোর্ট ইনক্লুড করতে পারবে।
আচ্ছা ঠিক আছে স্যার।
Okay, students. So by the time your instructor, sir, adds the two different pictures, okay, let us discuss about the simulation. So I think it's better if you simulate the CMOS gate instead of the CMOS inverter and NOR gate. Or the what you can do is you can simulate the CMOS inverter and CMOS NAND gate instead of the adder gate. Because although you have seen the physical demonstration of the circuit, but of course, I mean, unless you do it with your hand, it's never that clear. So it's better if you simulate it that way. You will have better understanding of it as well. And because CMOS is very important topic, right? So what you should do for your simulation for the lab report is implement or simulate, right, a CMOS inverter circuit and a CMOS NAND gate. Okay, you can note it down in your piece of paper. So you should implement a CMOS inverter and a CMOS NAND. Okay.
Okay, sir.
Okay.
Yes, sir.
So let's wait for our instructor, sir. Once he uploads the photos, okay, then I will proceed. সবুজ ভাই ছবি তুলে ফেলেছেন?
স্যার ছবি দিচ্ছি।
ঠিক আছে। Thank you, Shobus bhai. Students, I have received the picture, okay? So I will send them to the Teams classroom, okay? Okay, students, I have added the pictures Shobus bhai sent me, okay, in the chat box. You can find it in the chat box. You can download it from there. Can you see the photos?
Yes,
Yes, sir.
Okay. Okay, kindly download them. And thank you, সবুজ ভাই, আপনাকে অনেক ধন্যবাদ আমাদেরকে ডেমনস্ট্রেশনটা দেখানোর জন্য। Okay, have you all saved the file? Saved the different photos? সবাই ছবিগুলো সেভ করেছেন? Okay. Okay. Thank you. Okay. So for your lab report, you should do the simulation for the CMOS inverter and the CMOS NAND gate. Okay, then it will become more clear to you. And since you have seen the demonstration now, I think it is now much easier for you to actually try to understand that what is happening. And please thank your instructor, sir, because even in this situation, right, he is in the office just to show you, to help you with the circuit. Okay, so please say thanks to him.
Thank you, sir.
Thank you,
you,
sir.
থ্যাংক ইউ স্যার।
সবুজ ভাই, আপনাকে অনেক ধন্যবাদ। আপনি এই অবরোধের মধ্যে অফিসে এসে আমাদেরকে ডেমনস্ট্রেশনটা দেখালেন। Okay.
থ্যাংক ইউ স্যার।
Thank you, sir. Thank you.
Okay, so that's it for today. Thank you all for attending, and hopefully we will have our physical class next week on Wednesday. And I know there are few exams left, right? You still have, I think, 3 more days of exams left. So best of luck to all of you, those of you who have exams still left. Okay, thank you. And
Thank you,
it.
sir.
Okay, thank you.
Thank you, sir.
Sir.
Assalamu alaikum, sir.
Thank you, sir.
Thank you, sir.
Welcome.